Hello, my name is Russell Yates. Welcome to an overview of my upcoming research project for MIS 581, the capstone for business intelligence and data analytics. This research paper showcases a tech stack for data engineering and predictive modeling applied to potentially one of the most pressing national security issues of our time, that is, critical minerals supply chain in the United States. While the subject matter revolves around material science and economics, the true focus of this project is the end-to-end data architecture built to prepare, ingest, analyze, forecast, and visualize this potential national vulnerability. To understand our supply chain resilience, we have to look at the historical data. For this research, I will be sourcing a comprehensive multi-decade data set detailing U.S. critical mineral production compared to import reliance alongside critical mineral demand, utilizing reports from the USGS and others. The goal is to take national historical data and apply modern data science tools to uncover how our trajectory of domestic production capabilities compares to the forecasted demand. This analysis is to be grounded in formal statistical testing alongside some predictive modeling. The null hypothesis is that there is no statistically significant trend indicating an increasing reliance on imported critical minerals over time in the United States, suggesting that domestic production is keeping pace with demand. The alternative hypothesis states that there is a statistically significant upward trend in U.S. import reliance, coupled with stagnant domestic production. Failing to reject the alternative hypothesis could justify the need for additional investment. To test the hypotheses, I will be developing a data pipeline completely driven by Python. The first phase showcases data wrangling, cleaning the historical records, structuring them for programmatic analysis. From there, the scripts are used to automate the ingestion into a small relational database, allowing the project to update itself as new data is published from the sources. Once the data is structured and housed, we will use common data engineering machine learning models to predict future import reliance trajectories based on historical trends using confidence intervals. I plan to publish the predictive models and statistical findings alongside a beautifully formatted interactive HTML visual output. This dashboard allows stakeholders to dynamically explore the differences or lack thereof between domestic production and import reliance of critical minerals in the US, making the data accessible and actionable to all. From an IT management perspective, my specialization, reproducibility, and deployment are just as critical as the code itself. To ensure this entire environment can run seamlessly and be easily redeployed and explored by those who are interested, the application will be containerized using Docker and deployed onto a Windows machine as an example operating system environment. Furthermore, the entire code base from the ETL scripts to the Docker files to the visualizations will be thoroughly documented and hosted publicly on GitHub. This not only adheres to enterprise best practices, but serves as a transparent portfolio of my data engineering capabilities related to a topic of sincere interest in national security. In conclusion, this project and the data engineering pipeline built for it will test our hypotheses, determining if the U.S. is facing a critical and growing vulnerability in its mineral supply chain compared to demand. By rigorously wrangling, modeling, and visualizing this historical data, we can analyze the past and determine if the findings are significant. Findings in this paper will determine if there is an urgent need for investment in novel domestic extraction methods to expand the U.S. critical mineral production capacity and supply chain resilience going forward. Thank you for your time.